Hello, my name is Robert Fremont. I'm from the New Zealand Institute of Language, Brain and Behaviour at the University of Canterbury. This is the third video in a series of videos showing how to use our corpus annotation system called LaBB-CAT. In the previous two videos, I've shown how to install the software, set up a bit of a data structure and upload transcripts and recordings into LaBB-CAT. In this video, we'll be looking at some basic search functionality that you can use in LaBB-CAT. Now, the first thing we have to do is start up LaBB-CAT if we haven't already got it running. On Windows systems, there'll be a LaBB-CAT icon in your Start menu. On Macintosh systems, the LaBB-CAT icon is in the Applications folder, which you need to double-click on that to start up LaBB-CAT's mini web server. And once that's up and running, your web browser should open to the LaBB-CAT homepage. And here we are at LaBB-CAT. Now, in a previous video, I showed how to upload some transcripts. We've got various transcripts here in a couple of different corpora. In order to do searches on these, you need to go up to the menu at the top and click on the search option. Now, the first thing you have to do is select which participants, whose utterances we're going to search. You can search everyone just by clicking on the Everyone button, or you can decide that you're in fact only interested in a subset. Now, in this particular case, we are only going to search male participants' speech. So under the gender option, we are going to select male. When I select that, you will see that it will display a list of all and only the male participants. In fact, we are only going to be interested in this particular case in male speakers who are monolingual English speakers. And so we're going to select out of the languages box the English only option. And you can see here that it's whittled down our list of speakers to those that are male and only speak English. Now, there are various things that we can do on this page, but what we're interested in doing is searching. So we're going to click the layered search button at the bottom. And here you can see a list of all the speakers that we've selected. On the right, a list of layers that we might want to search. We'll look into those a little bit later. And at the bottom, there is the search matrix. It doesn't look much like a search matrix at the moment because it only has one layer in it and it's only one word wide. But we're just going to start with a basic search. We're going to search for all of the tokens of the word the. So we'll type that in the orthography box and click search. And these are the hits. Now, we've got a total of 392 hits, and it's only shown us the first 20. If we click on the first one, you can see that it opens up the transcript of that particular hit and highlights that particular hit, and it also highlights all of the other hits from the same search in the same transcript. Now, we've already seen what kinds of things we can do from the transcript page, so we're just going to close out of that now. If we want to list a few more results rather than 20, we can click on the Show 20 More Results list, or in fact we can show all of the results all on this page at the same time. Now, at the bottom of this list, you can see there are various buttons, and these are the things that we can do with this list of results. You can do these things with all of the hits that have come back, or only a selection of them. And what we're going to do is we're going to untick this box here, and you'll see that all of these boxes next to each of the hits has been unticked, and we can decide that we're only interested in this one, this one, this one, and this one. You can also in this list, in fact, use shift clicking to select a whole bunch at once. So for example, we might be interested in results from 20 to 25, so we click on 20, and then if I hold down the shift key while I click 25, it will select all of the ones in the middle. So having selected the particular tokens that we're interested in, there are various different things we can do. The first thing we're going to try is extract audio. So we're going to click on this button, and what it does is it goes through each of the results that we have ticked, extracts the audio of that utterance, and then puts them all together into a zip file. So we're going to save the zip file that is prepared for us. We're going to open that up to have a look. You will see that there's a list of files in here. Each of them is named after the transcript that it comes from and includes the start time and the end time of the utterance. And each of them contains just the utterance of that match.
Just how bad it was, and then over the other corner as well, Carlton Mill had done the same thing, and I think for the most part, where the building that Sergio Divino was in.
Now if we go back to LaBB-CAT, we can have a look at the next option, which is to convert. We would like to convert this to Parat text grids. So we're going to click the convert button. And again, this will give us a zip file that includes a text grid file for each of the results that we have ticked. Save that and open it. You can see again there is a collection of text grid files named after the transcript and the start and end time of the utterance. And if we open up one of those in Parat, you will see that it includes a tier for the utterance and in fact also a tier for individual word alignments. You'll see in a later video how to make these word alignments actually line up to the audio rather than being evenly spread throughout the utterance as they currently are. And now we're going to click the CSV export button. That gives us a CSV file with all of the ticked results in it. If we click save and open that up, it may open up in Excel or a similar tool. It's probably helpful to know that these are comma separated files. And you will see that there is a column for various different pieces of information. You've got the name of the speaker, the corpus therein, the line end time, an identifier for the match, the text before and after the match, and so forth. Now we're just going to close that for now and go back to our search page. We've seen that you can search for exact word matches, but you can also search for patterns using regular expressions. Now we're going to search for words beginning with THE. What we're going to do is, in addition to THE, we're going to add at the end a dot. And a dot means any character at all in a regular expression. And we're going to add an asterisk, which means 0 or more of the previous thing. And so dot asterisk means 0 or more characters. If we click search here, you'll see that in the results that come back, you'll see instances of the word the, but you'll also see other words like then, which is the followed by an N, they, there, and so forth. All words that begin with THE. Now we're just going to go back to the search matrix again. We're going to change that star to a plus. Now plus means one or more of the previous thing. So in this case, when we search, they have to be words that start with THE and then at least one character after that. So if we search for that, we will see that there are no instances of the word the anymore because THE followed by nothing doesn't match our regular expression. We've instead got words that start with THE and are followed by something else like then, they, there, and so forth. Now in regular expressions you can also search for a limited range of things. The dot searches for any character at all. We might be interested in a set of particular characters. What we're going to do now, for example, is change our E to be A-E-I-O-U enclosed in square brackets. Now square brackets in a regular expression means match any one of the things that are inside the square brackets. So here we are searching for TH followed by any of A-E-I-O-U followed by any character. If we do a search, you will see that now our results include anything that starts with TH followed by a vowel. Think, that, then, thought, and so forth. So regular expressions are a pretty powerful way of searching for patterns within your text and within your annotations. You can get more information about how regular expressions work either by clicking on the regular expressions link that's just here. That takes you to a page that tells you all of the different special characters that you can use. Here is one we've just used, the square brackets. You can also do negative searches for anything except what's inside the square brackets by starting with this caret symbol, and so forth. There are various different things that you can specify in regular expressions there. You can also get a little bit more help, of course, by going to the top of the page and clicking the help icon here, and it gives you a little bit more information about regular expressions with some examples here. Now what we're going to do is, in fact, we're going to make our search a bit wider. At the moment we have only been looking at identifying single tokens. What we're going to do now is we're going to, under this list of layers, there's a box that says search across 1 words. We're going to change that to 2 words. We're going to search across 2 words, and we're going to click Set Search Matrix. And now you can see that our search matrix is wider. What we are going to search for now is the word the, followed immediately by a word that starts with a vowel. So that's square brackets, A, E, I, O, U, close our square brackets, and then dot star for anything or nothing. Okay, now we're going to click search, and the hits that we get will now be 2 words wide. The earthquake, the one, the earthquake, the aftershocks, and so forth. Tokens of the word the, followed by a word that starts with a vowel. Now on the search page you can also play with some of the other options. For example, we have set here the followed immediately by a word that starts with a vowel. You can do that up to 2 words later. If we click on that search, you will see that there can now be intervening words between the and the word that starts with a vowel, the aftershocks, but also the other corner, as, the same thing, and so forth. So as you can see, regular expressions give you a fairly powerful tool for searching for patterns within your transcriptions. Now so far we've really only searched on one layer. In following videos we'll see how to set up other annotation layers for phonemic transcription, part of speech, and so forth. Once we've got some more annotation layers, the possibilities for searching for patterns becomes even greater. Thank you very much.